Today we're going to take a look at some more trigonometric identities. And really for the remainder of this chapter, we're going to continue to build the library of trig identities that you have available to you that you'll want to be able to use all through calculus. So today we're going to look at the negative angle identities and these identities that involve pi plus x. And you'll see that there are some similarities here. With the negative angle identities, remember what we're looking at with negative x, that indicates a negative angle rotation. So that's if you picture an angle that's in standard position, so it has the vertex at the origin and the initial side of the angle is on the positive x-axis. A positive rotation is counterclockwise, rotating up. These negative angles have that clockwise rotation, so rotating down. Okay, so these identities are here, and you should write them down. You should be familiar with what they are. The negative angle identities actually kind of make sense. If we're looking at the sine function, remember that sine is positive in quadrant 1, and it is negative in quadrant 4. The same relationship holds for angles in quadrant 2 and quadrant 3. Sine is positive in quadrant 2, and negative in quadrant 3. So if I have a rotation of some angle, we call it theta, the sine of that positive angle in quadrant 1 is positive. That same angle created as a negative rotation, so now that angle of negative theta has the same magnitude of sine, but the opposite sign, S-I-G-N, right? So the magnitude is the same, but the sign is opposite. And that's what this identity says. If you're looking at the sign of negative x, it is equal to the opposite of the sign of x. So how do we use this? Well, we might be looking at something like we're given the fact that sine of x is equal to positive 0.28. Then the sign of negative x is equal to what? And as we look at that, our identity says that the sign of negative x is equal to the opposite of the sign of x. So as we look at this, the sign of negative x is going to be equal to the opposite of the sign of x. So in this case, that is negative 0.28. Later, we'll look at how to find this value of the cosine of pi over 12. Okay, so pi over 12 is not one of the nice angles that you've seen on the unit circle, but it is an angle whose cosine or sine or tangent you could find using identities that we will introduce later. And so if we know that the cosine of pi over 12 is equal to the square root of 2 plus root 3 over 2, then what is the cosine of negative pi over 12 equal to? Well, our identity is that the cosine of negative x is equal to the cosine of x. And if you think about it in your head, that does make sense, right? Cosine is positive in quadrant 1 and positive in quadrant 4. Cosine is negative in quadrant 2 and negative in quadrant 3. So if we're looking at those rotations, the positive rotation and the negative rotation will have the same value because they'll either both, they'll be in quadrant 1 and 4 or they'll be in quadrant 2 and 3. So if cosine of pi over 12 is equal to the square root of 2 plus root 3 over 2, then the cosine of negative pi over 12 is also equal to the square root of 2 plus root 3 over 2. Okay, so this is a very useful identity and does get used quite frequently. Let's say that we wanted to use it to simplify, which is something that we did previously with the fundamental identities. We might be asked, in this case, secant of negative x times cotangent of x times the cosecant of negative x. And remember that our identity list that we had really only looked at sine, cosine, and tangent. And so the first thing that we would like to do is rewrite secant in terms of, in this case, cosine. So this would be 1 over the cosine of negative x times the cotangent of x over, and then let's rewrite cosecant as well, because we don't have an identity that tells us the secant of negative x or the cosecant of negative x. And you can find it. It's out there. But why memorize more than we need to memorize? Okay, so 1 over the cosine of negative x, that is going to be, based on that identity, 1 over the cosine of x. And I can kind of already see where things are going. So I'm going to change cotangent of x into cosine and sine, right? So cotangent of x is cosine of x over sine of x. And by making that change, I can start to see some of these simplifications happening. 1 over the sine of negative x, well, remember that the sine of negative x is equal to negative sine of x. Here we have cosine in the numerator, cosine in the denominator, so that simplifies. And so we're left with 1 over sine of x over negative 1 over sine of x. And, you know, how you choose to look at that to simplify it is completely up to you. But at this point, this is something, 1 over sine of x, divided by it, the opposite of itself, right? Negative 1 over sine of x. This is equal to negative 1, right? And you can flip and multiply to look at it that way also. Let's look at another example, right? So we're just trying to get comfortable and flexible with all of the different things that we can do with these identities that help us to simplify trig functions. And that's an important skill that we want to build as we move forward. And just, you know, as I'm looking at this and trying to simplify it, what can I do? Well, the first thing is recognize that the sine cubed of negative theta means sine of negative theta times sine of negative theta times sine of negative theta, right? So this is the way that it's written, that we're going to multiply the sine of negative theta times itself 3 times. And so our identity says the sine of negative theta is equal to negative sine theta, and this would be cubed. In the denominator, kind of looking forward and what's going to happen here, I'm going to go ahead and factor out a common factor of sine of theta, just because it looks like that's kind of where things are going. The numerator is bothering me because it's just not written correctly. So I'm going to change the way that it's written just so it's a little bit cleaner. And now I have a common factor of sine in the numerator and denominator, right? So this sine cubed becomes sine squared, and the sine theta in the denominator simplifies out as well. And I'm left with negative sine squared theta over sine squared theta minus 1. And I can feel you thinking, oh, simplify out, cancel those signs. You can't do that. Don't do that. And so the next thing for you to do is to look at the denominator and figure out how you can simplify it. So remember, sine squared theta plus cosine squared theta is equal to 1, right? So that is the Pythagorean identity that we looked at in the last chapter. And that means that sine squared theta minus 1 is equal to cosine squared theta. And so now I can simplify the denominator to be cosine squared theta. And so this looks like it's been pretty well simplified, but there is one more thing I can do. If you remember, sine over cosine is equal to tangent, and so I can rewrite this as the negative, or the opposite, of tangent squared of theta. And I'm done, and I've simplified the expression. Okay, so the more that that flexibility of thought, the more that you're looking at things and trying to figure out what you can do that might help you to simplify, the easier this process becomes.